Hello friends, compaction is a process by which soil particles are artificially rearranged and packed together into closer state of contact by mechanical means in order to decrease its void ratio and increase the dry density of the soil. The compaction process can be accomplished by tamping, rolling or vibration depending upon the type of the soil. In this program, we shall find out the relationship between dry density and optimum water content of the soil using light compaction as per Indian Standard Code 2720 Part 7. The equipment required for conduct of this practical includes compaction mold, detachable base plate, collar, metal rammer of 2.6 kg, balance, thermostatically controlled oven, IS sieve of 20 mm and 4.75 mm, steel straight edge, mixing tools, graduated jar with water, air dried soil sample, airtight container and water content determination equipment. First of all, by measuring diameter and height of the compaction mold, we shall calculate its volume. Volume is equal to area into height. That is A into H. Area is pi by 4 into d square into height. By putting the values of diameter and height of the compaction mold, this is equal to this comes out to be that is equal to, so volume of the compaction mold is 1000 centimeter cube. Record the volume of the mold in the prescribed proforma. To start with, take a representative soil sample of about 12 to 14 kg. Add water to it to bring the water content to about 4% if the soil is sandy and to about 8% if the soil is clayey. Mix the water in the soil properly. Now transfer this soil in an airtight container. keep it for a minimum period of about 16 hours for maturing. Clean the collar, mold, and base plate properly. Grease them lightly. Weigh the mold with base plate and record the reading in the proforma. Now attach the collar to the mold. Place the mold on a solid base. Now take out the soil from the container and mix the matured soil thoroughly. Divide the processed soil into 5 equal parts. Take one part of about 2.5 kg of the processed soil in a tray. Fill the soil in the mold roughly up to 1/3 of the total height. Now place the tamping face of the rammer on the soil surface in the mold. Lift the rammer fully and drop it freely. This imparts one blow to the soil. Ensure that the free fall of the rammer should be 31 cm. Continue giving blows by lifting and releasing the hammer by shifting the position on the soil surface. Compact the layer by giving 25 blows of the rammer. Scratch the top surface of this layer with the help of a spatula. Now place the second layer on this compacted layer. Again impart 25 blows uniformly distributed to this layer in the same manner. Now again scratch the top surface of this layer. place the third layer of the soil above this layer. Again impart 25 blows. After completion, ensure that the top of the third layer should not be projecting more than 5 mm into the collar. Now remove the collar. Trim off the excess soil projecting above the mold using a straight edge. Clean the base plate and the mold from outside. Weigh the mold with the soil and base plate. Record the weight in the pro forma. Weight of compacted soil, that is difference of W2 and W1. Bulk density is equal to weight per unit volume. Remove the soil from the mold using a tool. Take the soil sample from the middle portion of the soil for water content determination by standard procedure. In this case, water content is 8%. Dry density is the ratio of bulk density divided by 1 plus water content. So in this case, dry density is 1.78 gram per centimeter cube. Now add about 3% more water to a fresh portion of the processed soil and repeat the process. Record all the observation in the pro forma accordingly. Draw a graph plotting water content on the horizontal axis and dry density on the vertical axis. Join all the plotted points smoothly. This gives the relationship between water content and dry density for the tested soil. From the curve, read dry density and optimum water content, which is gamma D is equal to 1.95 gram per centimeter cube and water content is 11.25%. Once the maximum dry density and optimum water content of the soil is known, we can achieve the degree of compaction of the soil for different projects.